Welcome back to Boiler Wild. My name is Eric Johnson, and on this podcast, I like to talk about personal development as well as boiler industry topics. The boiler industry is one of the coolest industries, I think, and I love it. And in order to get better, we also have to better ourselves personally, and that will involve some work outside of our traditional career as human beings. I think we should all strive for excellence in everything we do. The name of the podcast, Boiler Wild. Wild is an acronym. Wild stands for work hard, invest in yourself, lead others, and develop yourself into a person of excellence. Today's topic is something that I've been trying to describe the layers of problems you'll find in the boiler room. And this is more of a service technician topic, but it can also be a operator or stationary engineer problems that you will find and see. And really it relates to more than just the boiler room, but I'm just thinking in the sense of the boiler room when I discuss these topics. So let's get into it. So there are five layers of issues that somebody can come across, and when they are doing their job, and then we're going to start at the lowest layer and then move up to the highest layer. The lowest layer is the easiest one to do, and most people start at or around that area. And I will also note that each layer is not mutually exclusive. Many problems will touch multiple layers at a time, but it'll be a percentage. So the more percentage of the lower layers means that the problem is generally going to be easier to solve, or the work is going to be easier. And then as you go up this hierarchy to the fifth layer is probably the hardest to solve and hardest challenge, and fewer people can solve it. So the first one is preventative maintenance. And preventative maintenance, there's a lot of topics and stuff that people talk about with preventative maintenance. A lot of manufacturing will push preventative maintenance, and it's a game of how little can we do and still get the product out the door. If you understand what it actually costs you over the full life cycle of your equipment, very rarely does that happen, but that's another topic for another day. But preventative maintenance, so think about somebody going out and nothing's wrong with the equipment. Your company has sold a quarterly contract or something, or if you're a stationary engineer, you're working inside of a boiler house, every single day, and you have to go grease motors and like listen to bearings or something like that. And that is relatively easy, as there's no fixes that have to be done, and there's very little accountability. So if you have 30 motors to grease and you have 2 grease points on each motor, and some of the motors are kind of harder to get to, and you kind of got to reach over the motor to get to the back bearing of the motor, and it's dirty and it's hot. If nobody greases that back bearing, who's really going to know? The motor doesn't just shut off and say, hey, I'm not going to run. Nobody greased the back bearing. So when you do preventative maintenance, it ends up being the ability of the person to spot problems. And if you are not highly educated and well-versed in the equipment that you are working on, and you don't have a lot of integrity and drive to push forward and find problems and look into stuff, and you just look at surface issues, or you don't even look at all, then preventative maintenance may be a waste of time and money. And that's just kind of how it is. But the people that do this stuff, like, companies are so short on people that doing preventative maintenance normally gets sent to the people who don't know a lot, and they're just trying to keep up with preventative maintenance on top of all the other issues. But like I said, if preventative maintenance is not done, stuff doesn't just immediately break or not run the day after. It will eventually, but it's not an immediate fix. And that's a lot of the times where the problems will get ignored or issues will get kicked down the road. Oh yeah, we skipped that PM for this month. We'll just do it next month. It's fine. It's no big deal. And if you can skip a PM for a month and just do it the next month, you may be doing the PM too often. Like, is it really necessary to do it every month? There's things to look at, but at the surface level, somebody doing preventative maintenance doesn't really have to think too hard, and they are just checking boxes most of the time, and there's no accountability to if they did it correctly. So on a burner, if somebody says, hey, we're gonna shut down your boiler quarterly, we're gonna pull the igniter, make sure the igniter's gapped properly, check the fan wheel. They make all these general lists of all this stuff, and then they just send somebody out to do it, and that somebody will look at that list and say, well, this isn't applicable, this isn't applicable, this isn't applicable, I'm not doing that. Yeah, I did that, but it doesn't really matter, so I'm just going to check it. I'll check that. And like, who's checking that the igniter actually got pulled and is gapped correctly, and they tested the strength of the ignition transformer, and they inspected the fan wheel for cracks? Like, nobody can say, unless you're video cameraing them, that they properly inspected the fan wheel for cracks. They may have looked at it and been like, yep, it's in one piece, and then checked it off. And most preventative maintenance is under the assumption that everything is correct, and they're just there to collect money and waste time, which a lot of companies see, and then they cut back preventative maintenance, and it's an issue. And it's not always the person's fault. Sometimes they just don't know any better. They haven't been properly trained, and they are too scared to get into anything. So then they kind of skirt around issues. They may not know issues, and they end up not doing preventative maintenance to how it should be done. And that's a lack of leadership and other issues on preventative maintenance. Preventative maintenance could be a whole series in itself, and we won't touch on that, but that is the lowest layer, number one layer, base layer of problems that somebody will encounter. And that layer is basically, there are no problems. We're just here to prevent problems, but nobody is making sure that we're actually preventing problems correctly. So then the next layer, layer 2, is direct replacement. This is customer calls, hey, I have this part, bring this part, replace it. Or you see a pump motor and you say, hey, we want a new motor. You take a picture of the motor tag, you order this motor, it comes in, swap out the motor, it's all good. Very, very little thinking was done. You change out a pipe nipple that was leaking, but it's an obvious replacement. And this is a lot of problems, I would say. A lot of things break, and they are still manufactured today. Like, we haven't been obsoleted on the part, or the design has changed or something that you've got to radically change it. So it's a direct replacement part, and it's very easy for somebody, especially if the part is 100% mechanical, that person can fix it and has the ability to take pictures of the old one and then undo the old one, take it out, put the new one in, and connect it. They may not know why it's connected, how it is, or what the part really does, or its purpose. Then they turn it on, and the customer says, yep, we're all good. That's right. Everything's good. So that's direct replacement. That's the second layer. Third layer, obvious issue fixes. So this may sound like the second layer, but it's one step up where you may have a part broken, you may have something that's bad, but you spot the issue and you see the issue, but it ends up being a little bit more of a challenge, whether the part's not available or the design was wrong of the part and it failed and you can't like put in the same thing because you'll know it'll fail again, like that, whatever it is. And the obvious issue fixes is where a lot of service techs and people in general top out at, where they don't bring any more knowledge, and the obvious issue fixes ends up being the most common occurrence of it is parts changers. So a parts changer will lack diagnostic skills, and they will see a part, and that part may be broken, may not be broken. They may not know how that part acts or how it works correctly. And then they go, oh, well, it's obvious this part's broken. And then they change the part. I also call that the see broken, fix broken, where somebody will go into a boiler room or something and they will look at a part and they'll say, yep, it's broken. Let me change that out. And they never look beyond the boundaries of that part on why it broke or what caused it to fail and all that stuff. And you can see this a lot with like a pump. A pump goes bad, it burns up, the impeller shatters or something, or the seals overheat, starts leaking. So then the obvious answer is, oh, well, the pump's bad, so we're just going to change it out. So then you change out the pump. And then 3 weeks later, you get a call, the pump's doing the same exact thing. May not even take 3 weeks, but we'll say 3 weeks. 3 weeks later, get a call, the pump's doing the same thing. And then you go, oh man, that pump, it must have been bad. So we'll change it out. We'll order another one. We'll send that one back for warranty. So then you change out the pump again. And you send the other one back for warranty. And then 3 weeks later, you get another call. Hey, that pump's bad. And then you go, man, I hate stuff that's made overseas. They just don't make them like they used to. And then you blame that pump. And then you may send somebody else out to the job to look at something or to change out the pump again because you ordered another pump. And then they go, yeah, the pump went bad because the strainer on the suction was 100% blocked and the pump was running dry and wasn't working correctly. And the outlet had a bad check valve on the pump. And that person unclogs the strainer, changes the check valve. Now they change out the pump again. So that's the third time they've changed the pump now. And now it runs. And now you have two pumps that were broken. The first one was sent back for warranty. And the manufacturer finds nothing wrong with it. And now the contractor, or even if you're in-house, you are stuck with the cost of two pumps because whoever was sent out there saw the obvious issue. Yeah, the pump was broken. We're going to fix that. See broken, fix broken. It's this mentality of just parts changing and not looking beyond the barriers of the part, which, like I said, most people stop at. Most people end up at that and never progress beyond that, and everything else is voodoo magic. So the next level of hierarchy is hidden energy. This is one I was trying to come up with a cool name. Hidden energy is as cool as I could come up with, but that is the fourth level of problem fixing. Is hidden energy. So that's like electrical, pressure, and temperature. Pressure could be air, steam, water, but the biggest one here is electrical energy. You cannot see electricity. If you do see electricity, you are doing something very wrong, and you should go the opposite direction. If you see electricity, that is not good. Electricity is hidden, and that's why I think it kind of freaks people out. It kind of freaks me out. You can open up a cabinet that's full of 480, and the cabinet and all the electrical components look the same, whether the electrical is on to that cabinet or not. So you open it up, and you could be working in a cabinet that's dead, and you're like, no problem. There's no electricity in here, and you're just ripping things out, moving wires, doing this, doing that. But then the panel is live, you open it up, and you're like, this is the scariest thing ever for me, because you're like, my hands were just in here 10 minutes ago, and I was ripping things out, doing this, doing that. And now, like, there's this hidden energy where I know if I would do the exact same thing that I did 10 minutes ago, all the difference of just one disconnect, I would be severely injured or die. And that's, I think, what gets a lot of people is they are visual and they can't see electrical energy. You can't see pressure. So air pressure, yeah, you can read it on a gauge, but you can't like look at a pipe and say, oh yeah, that's air pressure in there, and that air pressure is not the right pressure to move that valve, or that pipe isn't going to the correct tubing that goes to that actuator that is wrong. Like it's hard to see that. Same thing with like steam pressure. Steam will just fill pipes no matter what. And if you say, oh, like the steam pressure in that pipe before that heat exchanger is wrong, it's harder to know that. And temperature is the same way. Something could be hot, unless it's super hot, where like super hot red metal. But most things, temperature-wise, you cannot see. And you'll have a heat exchanger. Oh, heat exchanger's not working. What's the temperature on the inlet outlet? You have to now measure the temperature. It's a hidden energy, and that ends up being hidden data sources. That the heat exchanger doesn't just have an indicator that says, yep, I'm not working, I'm broken, I need fixed. If the temperature differential across the inlet and outlet of the heat exchanger is not correct, now you have to start going into other issues. But that hidden energy trips people up because they don't understand the fundamentals. They've kind of just hopped around and just poked around, got lucky, changed enough parts. And I think that's worked in the past, but now that parts are more expensive than ever, and time is more expensive than ever, and getting parts isn't always the easiest thing, this swapping out parts constantly and just fixing stuff till it works is not viable. So then they don't progress that past that point, because now they don't put in the work and don't understand the problems that they're having. But hidden energy, electrical, number one issue, I would say electricity. And the basics of electricity are the number one issue. I hear people saying, hey, my people need electrical training. They don't understand electrical. They don't understand wiring diagrams, how to use a voltmeter, how to measure amperage, all that stuff. And even if they do understand how to measure electricity on their voltmeter, they'll get a number, but they don't know what that number means. So it's way more complicated. And if you don't know what that number means or what number you're expecting, then you're just starting to poke around, and you start this poke method where you start poking around and you're basically guessing at the problem. And the only way to learn it correctly is learn the fundamentals. You have to learn the fundamentals of electrical components, how electricity works, amperage, voltage, resistance. You have to learn the fundamentals of pressure, how air pressure works, how pneumatic valves and everything works, compressed air. There's buildings out there that are all pneumatic control still. And while I would say it's probably worth it to upgrade to electrical, most people will look at it and say, oh, this is just old junk. Of course it doesn't work anymore. Like, it worked for 80 years. Just because you don't know how to work on it doesn't mean it's old junk. But it is worth it to upgrade. But a well taken care of pneumatic system will still work. Just the amount of people that know how to work on it is fewer and fewer every single day. Steam pressure, temperature, same way. Hidden electrical, number one, for sure. That's what people struggle with. They skip past foundations, and there's so much training out there that isn't training, it's just knowledge dumps. But there's a reason why this is the 4th layer of a 5-layer hierarchy, because so many people make it this far, yet problems will dip into this part. And that's where people struggle, because they only made it up to layer 3 with the competency that they have, and beyond that, they are stuck. So then the 5th layer is design issues. So this is the nothing's broken, but something's wrong. So you may have a customer install a new heat exchanger for whatever, and they have a big boiler plant, and nobody has ever done a calculation for how much steam we actually use versus how much steam we produce. And they install this huge heat exchanger coil, and it's steam, and it's got a 4-inch inlet, and they hook it all up, they open up the valves, and then all of a sudden, now nothing in their steam system seems to work correctly. And you would think that they would say, oh, like, the heat exchanger is the issue, but the problem normally shows up in the boiler. The boiler may have carryover or foaming because they don't have the proper water treatment, and they may not have the proper nozzle size on the exit of the steam. So now you're losing water to carry over into the header because of the increased demand. The boilers may be running at high fire because they can't keep up and maintain the steam pressure. There's all kinds of problems. But when somebody walks into the room, if they are a level 3 and they've only are observing the first 3 levels, they're going to be looking for something that's broken and a direct replacement. And even if the customer says, hey, we installed this heat exchanger and now the boiler doesn't run anymore, you would think that somebody would know enough to say, oh, well, the heat exchanger is the problem. The load is causing a problem. You must be not have enough steam for the load. Like, we'll have to do a load calc and, pipe sizing and all this stuff. And they don't have to know how to do all that, but it's, hey, this is where the problem is at. And if I don't know, like, we'll have to get like an engineer involved or something. But they should be able to know that. Well, a lot of people will just say like, oh, like, it's a brand new item. Like, that's not the problem. It's brand new. Like what's the problem? They just hooked it up to the system. Now the boilers don't run, and they don't make the connection that a heat exchanger 4 buildings away hooked up to a steam system could now be making the boilers act weird. So then they look at the boilers and they may look at combustion and say like, oh, maybe combustion's bad and the boiler's sooted and now it's not making enough steam and, whatnot. Like, I've seen all kinds of wacky stuff where people blame the boilers. The problem will show up in the boilers. They'll blame the boilers, and they'll start making like settings changes. They'll change settings. A boiler plant that's been installed 10 years and had no issues, and now the person is there and say, oh, well, some settings must have been changed. So let me change some settings. Let me change the PID settings for the boilers. While both boilers are, say you have 2 boilers, while 2 boilers are sitting in high fire, trying to make steam pressure with this heat exchanger that's wide open, that is now oversized for the amount of steam that you can produce. They'll be, oh, like, let me make some design settings and changes. Like, you're completely missing the point. You gotta take a step back, get above the obvious issues, fixes, direct replacements, and you have to now start looking at the hidden energy, which is the fourth level. But then you got to look at design issues of nothing is broken, but something is wrong. All right, we added this heat exchanger, and now when they open it up to the steam system, the boilers go wild and they have water level issues, and the water controls go wild. The feed water pumps can't keep up and all this stuff. Most people, as I said, would say, oh, we have a feed water pump issue, or we have a makeup water issue, or something like that. They don't connect that and say, hey, this heat exchanger is the problem. Like, you have too much load on your system. And once again, they don't have to know how to fix it, but it's the ability to identify it. I would say identification and the fix are in the same level, but I understand not everybody knows how to fix that. I wouldn't know how to, fix it. I'm not an engineer. I could tell them, hey, the heat exchanger that you just installed, it's got a 4-inch line, and, looking at this spec sheet that you guys printed off, it consumes this much steam, and, your boilers, the net, your output of your boilers is only, this much steam. So I don't know how much steam you're using throughout all your processes, but, with all your pipe sizing and, your net losses, like, you're obviously have been put over the issue. And if we turn off the heat exchanger and all the boilers level out and start working correctly again, the issue is obviously with the heat exchanger and it not being connected to a boiler system that can handle the loads of the heat exchanger. That problem is something I encountered that was real. They had a heat exchanger. It ended up being a 4-boiler system, but it was a chemical plant. They connected this giant heat exchanger to the steam system, and they couldn't make steam pressure after that. And they were like, something's wrong with our boilers. They don't make any steam pressure. It's because this heat exchanger was like a vacuum for their steam. Like, the boilers were, but the second a boiler made a pound of steam, that heat exchanger was sucking it dry. And 4 boilers in high fire couldn't handle the load. Now, they probably could have fixed all their traps and gotten the load under control, but they had tons of trap issues. But over time, they lose all these inefficiencies, and they just kept tacking on more problems and more equipment to their steam system without changing the central plant or, changing what is happening or doing load calcs. And they finally tacked on this giant steam heat exchanger to heat some cold air, and that put it over. So that was a real problem. I've seen other problems where there'll be a commercial laundry, and we're talking like Cintas like level. If you don't know, Cintas is like a giant uniform service, and they'll have these giant steam tunnels, and they'll have everything on a solenoid. So the steam tunnel will call for steam, and the solenoids will open, and it's a instant demand. So a solenoid will pop open, so it's either closed or open. So all these coils or whatever load pops open, and these steam tunnels are just a giant load of steam that's instantaneous. And boilers do not do instantaneous steam loads. You don't just call for steam and just have steam. The boiler has to boil all the water, turn it into steam, and send it away. So you have this instantaneous steam load come on, and the boilers go wild. Pressure drops to basically nothing. The water levels go all over the place because they're not maintaining their chemical. They have too high a TDS. and then it ends up tripping on low water. The boiler starts cycling, and then they get wet steam because now they have carryover. They are overloading their header with water. Then they start having water hammer, and pipes start swinging and banging, and it causes all kinds of ruckus. And they call somebody in, and then they say, hey, something's wrong with our boilers. They're not running correctly. They keep going off on low water. Feed water pumps are running all the time, all this stuff. And the person looks at that, and then they fail to mention, oh yeah, we just finished commissioning a giant piece of equipment that we call a dryer tunnel or whatever, and it's a steam tunnel, and it's a huge steam load. Like you'll get that. A good person, a good service tech will walk into the room and say, all right, did we do anything new? When did this start happening? Did you guys change anything? And those exploratory questions are the difference between somebody who just looks for the obvious issues, see broken, fix broken, and they just want to replace something, versus somebody looking at design issues, because somebody with a higher level of knowledge and thinking will understand that a boiler plant that has ran fine for years and years and years doesn't just one day just start acting crazy without a good problem. And if it starts acting crazy, there's probably a general problem spread across the boiler plant that will cause that issue. So it's not going to be an individual issue with a boiler. Normally that problem, if it's inside the boiler room, will be water treatment. If you get too much chemical in your boilers, they'll start tripping on low water. You'll start getting bouncing water levels, foaming, carryover, all that jazz. And people think, oh, our low water cutouts keep going off, and then they'll hear their feed water pumps going crazy. If they're on off, they're kicking on and off all the time. They can't, or they're running all the time and they can't keep the boiler full of water. So then they think, oh, well, your feed water pumps are bad. No, it's a chemical issue because it's happening in all three boilers. The likelihood that all three feed water pumps are just bad and don't fill three boilers at the same time when they filled each boiler the same time perfectly for the last 20 years is pretty low. So when you start having problems across multiple pieces of equipment, across entire plants, you gotta notch yourself up and start looking for bigger issues. Now there could be a obvious fix, a part that is broken, but that part is going to be something that is going to affect the entire plant. I was involved in another job. I'll spare the details of most of the job, but the brand new building had hydronic condensing boilers, and they did very little maintenance, preventative maintenance on it, and there were tons of issues from commissioning in this brand new building. They were under the assumption that brand new means we don't have to spend money on maintenance, because why would we spend money on something that's new? Where if you are not aware, mechanical things from day one need maintenance, and it's not going to need as much maintenance as something that's 20 years old. But every mechanical system will need preventative maintenance, whether that's filters in your air handlers or water testing in your hydronic loop and all that stuff. But there ended up being a bypass valve that, I don't know if it went bad, but it was bad at that time. But like I said, there was tons of commissioning issues, and this bypass valve at the end of the loop was stuck closed, and the actuator had popped off the valve and had broken and wasn't moving, and they were constantly having flow issues, and the boilers could not stay on because they didn't have enough flow, and nobody wanted to look at the problem for what it is. And they're like, oh, it's a boiler issue, it's a pump issue, it's a boiler issue, it's a pump issue, it's building controls issue, which points to the pumps, which points to the boilers. Everybody's blaming everybody else. But then, somebody that knows hydronic systems, I go in there and I say, all right, we've been having flow issues from day one. It's probably not a controls issue, probably not a pump issues. The pumps aren't even running at 100%. Everything seems fine and normal here. What affects flow? And do we have a bypass valve? So then you look at the prints. Here's the valve. So then you go find it in the ceiling, and then you find it's wrong. Then you crank open the bypass valve manually, and then all of a sudden the boilers are able to run correctly and have the correct flow, and there's the correct pressure differential between the supply and return, and now the control sequences start working properly for the building controls. So it was a low-level problem, but the issue was starting to be high level, and it was causing whole building issues, which was affecting heating. And it's easy to think when somebody goes in there and say, oh, your building's not heating, that's an engineer issue. I can't solve that. I'm not an engineer. Something must be wrong. If you start going through the basics and start narrowing out what actually is the problem versus symptoms, you can most likely find the problem. You may not know the answer to the problem, but pointing at a broken control valve and saying, hey, that control valve is broken. I don't know if that control valve is sized correctly, but that is what's causing the issue, because we can't bypass flow between our supply and return, and that valve is closed, and we need to look at the sizing of the valve, make sure it's correct, all that stuff. But that's the 5 layers. That's what I've come up with for 5 layers of problems in the boiler room, 5 layers of challenges. We'll recap. So preventative maintenance, there's really no problems. Somebody's just checking off some boxes. It's up to the person to find problems, to spot problems. It's really preventative maintenance really should be a high-level activity, as it's very important, but it most often gets delegated to the most low-level people on the totem pole who normally don't know a lot, and they ended up just doing preventative maintenance just to do it and not actually prevent maintenance issues. Next step up, direct replacement. This part is bad. I'm going to change this part. No outside thinking of that. Next step up is the obvious issue fixes. This pump is bad. This low water cutoff is bad. It's not working. The low water cutoff is tripping. I know there's water in the boiler, so this low water cutoff is bad. I'm going to change the low water cutoff. It's an obvious issue, and a parts changer changes it, and then they find out that the low water cutoff isn't bad, but it was actually water treatment. The low water cutoff couldn't sense the water in the boiler. That's now a higher level of thinking. So then you have hidden energy, electrical, pressure, temperature. Hidden energy, most likely electrical. Electrical troubleshooting is the number one skill that somebody needs to develop in order to look at problems and solve problems, as everything is basically electrical these days, and you have to understand the fundamentals of electricity and how it works. Same thing with pressure, air pressure, steam pressure, water pressure, and understand how pressure flows through pipes and a system and containers, and then how temperature affects things, how hot water is different than cold water, and why a heat exchanger can be hot on one side and cold on the other side. So that's hidden energy. You can't see it. You may be able to detect it with a meter or something, but you're not able to visually see the problem, most likely. And then the next step up is design issues. Nothing's really broken, but it is wrong. And like I said, all the previous examples that I talked about, you can also have wet steam issues with sterilization. Hey, our boiler's running correctly. It was just installed. We have a brand new hospital. Everything seems to be correct, but we have wet steam. Our sterilization process is going bad. We have a lot of rejects because we have water and all this stuff. And then it can be as easy as, oh yeah, your drip legs are not properly sized and you have water you have steam that's condensing in your piping, they can't get out, and that's what's causing your wet steam. Like, it can be a very easy fix, but it's a design issue. If somebody that's lower level thinking goes in there and says, oh, like, you have wet steam, well, I don't see any problems. Like, I don't see any steam leaks. I don't know why you'd have wet steam. They don't even understand design issues that would cause wet steam, or what's dry steam, or how you even make dry steam. So it's a higher level of thinking, and I think that's the highest level. You don't have to be able to know how to fix it, but it's just spotting the problem and finding the root cause can be somebody else's issue, and that's why normally most people work with a company of other people, and hopefully that company employs people that are smarter than you. And you can call somebody, you can refer it to somebody, you can even refer it to another company and say, hey, we have a wet steam issue. We're not steam experts, we're just a mechanical contractor. Let's bring in a steam person. We know it's a design issue with this piping because everything is correct, but for some reason we're getting water. And then that steam person comes in and says, oh yeah, you use the wrong traps, that drip leg is improperly sized, and we have improper sloping here. Fix those, and we should have dry steam and fix all your problems. Then you fix it, and then you have dry steam. So it's just this higher level of thinking that you have to understand the fundamentals, understand why everything happens, and it's really understanding the big why behind everything. If you just see things for how they are of, oh, that's broken, I fix it, that's the issue, I fix that, and you don't understand why it's the issue or why something caused that, that's another high level of thinking that most people don't achieve, because that is harder to teach. And quite honestly, I don't believe everybody has the mental capacity to think like that. Not that people are specifically dumb, but not everybody can handle a higher level of thinking and challenges. And when the skilled trades, especially in the boiler industry, but the skilled trades, when they typically don't recruit the best and the brightest people, not to say that everybody's dumb, but normally the best and brightest go off to college and get steered away to other industries, or they become engineers and sit in an office. They never see a real piece of equipment themselves. So the people in the field, your stationary engineers, your operators, your service technicians, are normally not the people that excelled in school and took thermodynamics and did all this stuff and have this drive to understand the why and are smart, quote unquote, academically. Like, that's typically not people who do that stuff. Most people who become a service tech or an operator, whatever, they love working with their hands. That's the number one thing you hear is, well, I'm just a hands-on learner. I have to see it. They're very visual learners, and while that may be true, that's just their preferred level of learning. The ability of somebody to understand problems that has higher variables than the lower level issues that I talked about, I just don't think everybody has the mental capacity to learn or even the drive to learn. Most people don't want to learn that much. They don't care about their job that much to get that involved with it. And it takes more than a 9-to-5 thinking to really get down and learn the true why behind everything. Not that it can't be done, but you can't, just like, you can't lead a horse to water if it doesn't want to drink. If somebody doesn't have any reason or drive to learn something higher level and they get paid being a parts changer, then why would they want to learn anything higher level? They like where they're at. So that's the 5 challenges. I hope that kind of made sense. I've been thinking a lot about that the past couple months, and I'm sure there's some psychiatric person or something, psychology, that has put this into something fancier, but that's how I think about the 5 challenges in the boiler room. And I hope you enjoyed this. It may seem kind of like a rant, but hopefully I put it into somewhat of a knowledge structure for you. That's part of this podcast. I am learning to communicate, and clearly communicating ideas is not the easiest, especially when you are talking to yourself and you don't have somebody to bounce ideas off, or to like have them repeat your ideas back to you and have insights and have a conversation. And that's why guests are coming at some point on this podcast, Boiler Wild. So if you want to be a guest or recommend a guest, you can email me or DM me on LinkedIn, but you can email me eric.johnson@boilerin.com. If you have any questions, you can email me. If you have a review, leave a 5-star review. That would be amazing. I appreciate you listening. This is the 17th episode of Boiler Wild. We are just getting started. It's going to be a great ride. So have a great day and stay wild.